We are going to practice counting the number of carbons and hydrogens in each molecule. So we're just going to do this first part of the worksheet, counting hydrogens and carbons. So we're going to start by counting our carbon atoms. And remember that every single line segment represents a carbon-carbon bond. So I'm going to draw dots the beginning and end of every single line segment. Each one of these dots represents a carbon atom. Even ones that are two lines, that represents a double bond. That's still a normal bond between two carbons. So out here on this end, we've come across a new situation. We have oxygen atoms in the molecule. There's a carbon right there. A bond like this one that we're looking at right here to an oxygen atom, when there's a bond to an oxygen atom, there is no missing carbon or invisible carbon. There's no carbon right here. Sometimes some students think that there should be a carbon atom right here, right before the oxygen, but there is not. There's no carbon atom right there. And likewise, in this other carbon-oxygen double bond, there isn't a carbon sitting right here either. That's just a bond. This is a bond between a carbon and an oxygen. So we found all of the carbon atoms. Let's count them up. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 carbons. And before we count the hydrogens on this molecule, let's go over to vitamin A and let's practice counting carbons again. So same thing, we're going to just draw a dot at the beginning and the end of every line segment, and I'm going to try to count these as I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 carbons. Remember, there is no carbon here before the oxygen atom. Let's go back and count our hydrogen atoms. So when we're counting our hydrogen atoms, we want to remember that the carbon atoms all like to have 4 bonds. And if we cannot see all 4 bonds around a carbon atom, that means it has some invisible or hidden bonds to hydrogen. So we're going to look at each carbon one at a time and ask ourselves, how many bonds can we see? How many bonds must be hidden? We've already drawn dots on all of the carbons, which is going to make it easier for us to find. And what I'm doing now is just looking at each dot. How many bonds can I see? How many bonds can I not see? So out here, we're at this guy right now. This guy has got 1 bond to the left, 1 bond to the right, and it has a double bond sticking up. A double bond counts as 2 bonds. So that means that this carbon atom that we're focusing on has 1, 2, 3, 4 bonds. That means it's got all 4 of its bonds, no bonds to hydrogens for this guy. Going around the ring clockwise, our next carbon in the ring, we can see 1, 2, 3 of its bonds, so it's got a 4th bond to hydrogen. Next carbon over, we can see 1, 2, 3, so that means it has bond number 4 to a hydrogen. Next guy over, we can see 1, 2, 3, 4, so it has no hydrogens. Let's keep going around the ring. The next guy in the ring, we can see 1, 2, 3, so it has bond number 4 to a hydrogen. And the next one, 1, 2, 3, bond number 4 to a hydrogen. Now let's move along. Our next carbon over, we can see 3 of its bonds, so it's missing we can't see one of its bonds to a hydrogen. Up here, this guy, we can only see 1, so that means it's got 3 hydrogens that we don't see. Last but not least, we've got this carbon. We can see 1, 2, 3, 4 bonds, so it doesn't have any hydrogens. And don't forget this guy. So let's count up how many altogether we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 hydrogens on this molecule. Let's try vitamin A. Looking at all of our carbons, and we're going to ask ourselves how many bonds can we see? How many bonds must be to the hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. None on this guy. None here. None here. 13, 14, 15, 16, 17, 18, 19, 20, none here, 21, 22, 23, 24, 25, 26, none here, 27, 28, 29, and don't forget this guy makes 30 hydrogen, if I counted that up right. Let's move down. We're going to do just one more of these. Let's do L-Dopa. So again, let's start by finding our carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 carbons on this molecule. This bond right here that looks kind of like a triangle, you might have seen that in 121. We call this a wedge, and we will learn more about wedge bonds later. It's just it just represents a single bond. So for now, when you see it, you can just treat it the same as a regular single bond. Let's find our hydrogens. Don't forget these guys. We have 1, 2, no hydrogens on this carbon or this carbon. 3, 4, 5, none here. 6, 7, 8, 9, 10, 11. 11 hydrogen, if I counted that correctly. Now, for the other 3 molecules on this page, they're bigger and they get trickier. And if we were meeting in class in person, we would definitely go through these as well. But since we are online, I'm trying to keep the content not super complicated. So I'm not going to go over how to count the carbons and hydrogens in these remaining 3 molecules. However, if you feel like you're up for a challenge and you want to try on your own to figure this out, I can go through it really quick. You can check your work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 carbons. And the hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I'm looking to see if I missed any. I don't think that I did. And again, this is pretty complicated, so if you feel like you can't follow along with this, don't even worry about it. That's fine. Let's look at fluoxetine for the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And its hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hopefully I'm not missing any of them. And then last but not least, cocaine, carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Pretty sure I got all of them. Again, if you're having a hard time counting them on these last 3 trickier molecules, don't even worry about it. I feel like you should definitely be able to do the first 3 that we did. The last 3 are quite a bit harder, only for students that are really, really comfortable with this material.